Good evening, everyone. Welcome back to the world of fire alarm. We are still in module 6 because it's a monster. We're going to get through module 6 tonight, and I'm hoping we can possibly start to dig into module 7. And then next week we'll be able to finish off module 7 and talk about the assignment, which will give us a couple weeks to get the assignment done, which is plenty of time. So last week we were talking about manual initiating devices, our pull stations, and the various types and how they work and all that stuff. And then we started talking about heat detectors. Right? We talked about our fixed heat detectors and our rate of rise heat detectors and advantages and disadvantages of each and the mounting locations. And we saw how incredibly complicated it can get. Usually it's not that complicated, but there are jobs that it becomes a giant nightmare. And now we'll talk about smoke detectors. On a technological from a technological standpoint, smoke detectors, they are much more modern than heats and pull stations. Uh, Smoke detectors really didn't come on the market until the 50s, and they were monsters in the 50s. The smoke detectors that we see now, that size, that form factor, that kind of functionality, really didn't start to exist until late 70s, early 80s. Right. So it's pretty recent technology uh, for the world of fire alarm. They have gotten so much better over the intervening decades, which is great. Right. So we've got our smoke detectors. Uh, our smoke detectors, some of them are designed to operate at the smoldering stage of the fire. Some of them are designed to operate at the incipient stage of the fire, which is the first stage of fire. They are sometimes, and sometimes is in giant air quotes, called product of combustion detectors. No one calls them that. Uh, I'm sure someone has at some point, but yeah, no one calls them that. We call them smoke detectors. They are detecting the products of combustion because that is what smoke is. It is the products of conduction, of combustion. So from S524, smoke detector is a fire detector because it still falls under the umbrella of a fire detector designed to operate when the concentration of airborne combustion products exceeds a predetermined level. And that the predetermined level is it's decided at the factory. The adjustments, the sensitivities are set at the factory, and then they put some uh, schmoo on it, basically like a caulking compound to make sure that no one can mess with them later. So we go back to 32412 in the building code. Right? If a fire alarm system is required, smoke detectors shall be installed in. And here's where we have to put smoke detectors. Uh, Last week we looked at where we put heat detectors and fire detectors. If they call for a fire detector, we can put in a smoke, right? Because a smoke is a valid fire detector. Generally speaking, we don't because of the costs involved. Smoke detectors are much more expensive. Heat detectors are cheap, so we throw those in wherever we can. Uh, but smoke detectors have to be installed in certain places. And this is whether or not a building is sprinklered, right? Sprinkler heads are fire detectors. They function under the exact same principles as fixed heat detectors. They do not detect smoke. So we cannot replace smoke detectors with sprinkler heads. Does not work. So even when we have a sprinkler system, we have to put in smoke detectors. I actually threw in a couple of smoke detectors today, um, as required here under A. If a fire alarm system is required, smoke detectors shall be installed in each sleeping room and each corridor serving as part of a means of egress from sleeping rooms in portions of a building classified as Group B major occupancy. So I'm doing renovations in a hospital. Hospitals are Group B occupancies. It's a B2 occupancy, care and treatment. And uh, we're doing an ER redevelopment. So in the patient rooms inside the ER, they are considered to be sleeping rooms because patients do sleep there overnight. And right, it is a bed space, so it is officially a sleeping room. So we put a smoke detector in the sleeping room, and then each corridor serving as part of a means of egress from sleeping rooms. So what that comes down to is you leave the sleeping room, the patient room, and you walk towards the exit, and every single corridor you walk down is going to have smokes in it. So I installed a couple of those today. I didn't do much. I haven't done much firearm this week. I've mostly been doing light fixtures and stuff like that. Oh, I'm exhausted. My arms are sore. This whole doing real electrical and actually using tools all day, wearing a tool belt. Oh, yeah, I haven't missed it. That's for sure. Then we also need to put smoke detectors in each room in a contained use area and corridors serving those rooms. So if we have a ward that is locked down for uh, mental health or acquired brain injury, Alzheimer's, dementia, anything like that, right? Uh, oh no, sorry, that's impeded egress zones. Contained use areas. Contained use areas, that's our jail cells, right? We have to put a smoke in there. And then all the corridors. And then each corridor in built portions of a building classified as Group A Division 1 major occupancy. Group A is assembly occupancies. Division 1 is assembly occupancies intended primarily for the viewing of the arts, like theaters and such like. So all the corridors get them there. Each public corridor and portions of a building classified as Group C major occupancy. Our hotels, our apartments, our condominiums, the hallways get smoke detector. We put one in each exit stair shaft at the top, of course. We put them in the corridors of elementary and secondary schools, and we put them in each elevator machine room or machinery space. Right? If we have an elevator machine room, it gets smoke detector. If we just have like a elevator machine cubby, right? Because some of them are just tiny closets, yeah, it gets one in there as well. If we're dealing with escalators, the machinery space is typically right under the escalator. The smokes go in there. Right, so that is where we need to put smoke detectors specifically. Not a lot of spaces that we have to put them. Right? But if we have a building where we need to put them in, we can end up putting in a lot. Right? Uh, corridors in a school, yeah, maybe a couple dozen, not a whole bunch. Uh, Group C major occupancies, depending on the size of the floor, we could have 8 or 10 on a floor, right? So 10-story building, there's 100 already. But when you get into hospitals, ooh, there's a lot of smokes in those buildings. They are everywhere. We're talking hundreds and hundreds and hundreds. of smoke detectors, right? Because it's not just the patient rooms. The big one is the corridors. There's a lot of corridors in a hotel. And then part two, which we looked at last week, was location of heat detectors specifically. Now, of course, if it's a fully sprinklered building, we don't need to put the heat detectors in because sprinklers are the same as heat detectors. Right? And well, we already looked at that, so we're not going to look at that again. The things we have to do in addition to just throwing in smoke detectors, though, it gets a little bit more complicated. Is well, zoning is pretty vague, right? Oh, there's a fire in this wing of the hospital on this floor. Well, that's good for the firefighters. That's not really good for the people in the building, right? Because, well, if they're in the hospital, they might not be able to get out of bed. And if they're in like a detention occupancy, they're not allowed out of the room. So we need to know exactly where the smoke detector is activated. So our smoke detectors required in sleeping rooms of care and treatment, or detention occupancies shall, upon actuation, provide an audible and visible signal to staff serving those rooms so that the room or location containing the smoke detector can be easily identified. And we tie that into the nurse call system. Right? The was it the modern nurse call systems that are, basically Cat 5 cable and all that. Typically, there's a set of contacts on the dome light for the room. And so you bring your two wires from the relay base of the smoke detector to the dome light. So when the smoke detector activates, that relay changes state, and the dome light starts blinking red, and it starts sounding, and the nurse call system at the nurse's station uh starts the whole thing starts blinking red and tells you which room it's in. Pretty cool. Works pretty well, not very difficult to do on the modern system. If you're working with a nurse call system that's like 30 years old, oh, good luck. They're nightmares. Luckily, they're almost all gone now. The smoke detectors required by Clause 1G, which is 1G, elevator, machine room, or machinery space. If we have a smoke detector activate in the elevator machine room, we definitely want to stop using that elevator. That's definitely not a safe thing to be doing. So we are going to recall the elevators. So again, we're going to use a relay base. If smoke detector in the elevator machine room activates, it's going to send a signal to the elevator controller, and it's going to shut down. Now, the modern elevators that I've been doing the last few years, right? Yes, they call for it to recall the elevators. They recall it to the nearest floor. Right? They don't bring it down to the ground floor if there's a fire in the elevator machinery room. They just want it nearest floor and lock the doors open because it's a lot safer to be not in the elevator if there's a fire in the elevator machine room. Yes, there's lots of redundancies and fail safes and all that, but we still go for it. And if we have fire alarm systems in a building, and if we have walkways or vestibules, walkways and vestibules in this case, we're talking about walkways to other buildings and vestibules that tie us into other buildings. If we can get from one building to another without going outside, this is what they're talking about. we have to put in smoke detectors near that entrance so that if there's smoke coming from the next building over, we want to know about it. There are exceptions to having to put smoke detectors in because sometimes smoke detectors can be problematic. They can be quite sensitive. And if, because of the nature of the occupancy of the building, we're going to get a lot of false alarms, yeah, we can not install the smoke detectors. We can put in alternate fire detectors. For example, group F occupancies, industrial occupancies. Right? If it's a welding and fab shop, there's going to be a lot of smoke in the air. Like, yeah, the we're going to have the smoke eaters and good ventilation and all that stuff, but there's still only so much you can do. So maybe we don't put the smoke detectors in. Maybe we put in heat detectors instead. So there's an exception that we're allowed to do that. We can also do that in areas that are subject to freezing. Parking garages. Parking garages have stairwells. And according to the building code, we have to put smoke detectors in the stairwell. But unheated parking garage, unheated stairwell, that smoke detector isn't going to work properly because smoke detectors need nice environment. It needs to be, suitably warm, not too hot, not too cold, not too humid, and all that for them to work properly because they are electronical devices. So in stairwells like that, we can put in heat instead of smokes. There are two different types of smoke detectors. There are photoelectric and ionization smoke detectors. If we're looking at them installed on the ceiling, it can be really hard to tell which one is which. Unless you spend a lot of time with the specific manufacturers, you might be able to tell the intricacies of each. But if you take the head off the ceiling and look at the back, it's really easy to tell if we have a photoelectric or an ionization, because an ionization uses americium, radioactive, right? So there's going to be the radioactive symbol on the back. As soon as you see that, you know it's ionization. So our ionization and photoelectrics, completely different process, completely different technology. And the degree of effectiveness depends on the characteristics of the fire. Right. Photoelectric smoke detectors. This is the second technology that they came out with. They use ionization types. That's the first ones that were invented. Photoelectric, a lot simpler to build with the technology that we have now, and not radioactive. So that's kind of a good thing as well. We're using light. The smoke enters a chamber. There's a chamber inside, and the light gets reflected by the smoke, right? Because it is an absolute black, baffled chamber, right? So no light is being reflected. Uh, we put the smoke in, and it starts to reflect, and that reflection goes to the light sensor, and it initiates the alarm. They work best at detecting large smoke particles during the smoldering stage of the fire, which is the second stage of the fire, visible products of combustion, because we need enough smoke and large enough smoke particles that we can reflect light off of it easily. Ionization smoke detectors, they use the properties of ionization. The smoke enters the chamber, it interrupts an ion flow, and that interruption initiates the alarm. It worked best at detecting very small smoke particles. The big black smoke that you see when you're starting a campfire and stuff like that can't be detected by an ionization smoke detector. Those particles are too big. We actually have to filter out those big particles. We're only looking for the small stuff. So they're great at very small smoke particles produced in the incipient stage, which is the first stage of fire, and the flame stage, the third stage. They don't work well in the second stage. Right. So ionization smoke detectors, right? We have electricity. Uh, we have a very small amount of radioactive material positioned between two electrically charged plates, which ionizes the air and causes the current flow to flow between the plates through the air gap. When the smoke enters the chamber, it disrupts that flow of ions, so it reduces the current flow, and that reduction of current flow activates the alarm. And it works quite well. We're susceptible to certain things, uh, like thunderstorms can set off ionization type smoke detectors because of the massive amounts of ions just in the air from the lightning and such like. Photoelectric smoke detectors. We have a light source and a light sensor, right? If we throw light into the chamber and it doesn't come back, everything is good. If we throw light into the chamber and it reflects off of the smoke and hits the receiver, then we have smoke. So we have a fire. So that's how it works. Now they have figured out how to avoid false alarms. The light emitter and receiver on a uh, photoelectric type smoke detector, it's hidden behind a lot of baffles, so just shining a bright flashlight at it is not going to set it off. And the light emitter is not just sending out a steady beam of light; it's a pulsed beam. It's been coded so that we can reduce false alarms. The receiver needs to get that same code of the blinky blinks, and then it's going to work properly. Ionization type and photoelectric type smoke detectors are power consuming devices. We need electricity to make them work. And so they're going to consume electricity. Uh, there is a certain amount of computing power that has to be used to be able to figure out if there's an alarm or if it's not. Now, that's not what they're using in the 50s. Ionization type lends itself better to having no computerization. Photoelectric, uh, you can do it with no computerization. It just works a lot better with computerization. And everything has little microprocessors built into it nowadays, which is one of the reasons why they're less prone to false alarms. If you put a little tiny computer in there, it's also now able to do some self-diagnostics. It can monitor its own sensitivity and operational status, and it can compensate for dirt. Right? The dust accumulation over the days and months and years that it's in use, it's able to tell that it's getting dirty and adjust its threshold over time. So we used to have a lot of issues with as it got dirtier and dirtier and dirty, it became more and more sensitive, a lot more false alarms. That's less of an issue now, partly because of the baffle designs, but also because the drift compensation has gotten so good. Uh, but eventually, there's just going to be too much. Eventually, it's going to get too dusty and dirty in there, and it's not going to be able to adjust anymore, and it's going to try to send a signal. It's going to use the blinking LED light to tell you that it's gone out of range and you need to replace it. Really hard to tell because you have to pay very close attention to how fast and how often that light is blinking. So usually, once you get a few false alarms, you just replace the head. So our smoke detector drift compensation. Uh, in the addressable world, this stuff does really, really good job. In the conventional world, it's pretty good, but not great because of limited processing power, but also limited communication abilities. On a simplex addressable system, if you have a photoelectric smoke detector that gets too dirty and it has to get changed, you get a trouble on the panel, and you go to it, and you know the trouble, and it tells you, you know, photo detector, this address, this location, excessively dirty. Like there's no guesswork involved. Like it's too dirty, change it out, right? And all the other manufacturers have similar similar things. I really like the simplex one because excessively dirty. That's just it's poetic. Um, with our conventional systems, when it hits the sensitivity limits, uh, it might place the zone circuit into a trouble condition. It does. They don't always. Depends on the specific device, specific manufacturer. Um, Often we just get false alarms. So that's one of the reasons that we have to do our annual testing to make sure that they are working within the proper thresholds. And if you notice that it's getting dirty, clean it or replace it before it becomes an issue. Because there are limitations. They can only do so much. Right? Our smoke detectors are better at detecting fast flaming fires than slow smoldering fires. Right? The uh, ionization ones are better at picking up the slow smoldering fires than the photoelectrics. Uh, if you if you have a lot of burnt toast alarms, that's usually an ionization device. Uh, because burnt toast is very, very small products of combustion. Uh, we can have issues. Sometimes you think a smoke should have gone off and it hasn't. It might be the next one down, the hallway that picks it up. And it could just be because of the nature of the airflows. Uh, or, that first one was very, very clean. The second one was a little bit on the dirty side, so it was a little bit more sensitive. I mean, it can be a little bit hit and miss. But also, if you have a smoke detector that's in the path of a fairly fast-moving, dirty fire that's just blowing all sorts of black smoke, the smoke detector could get basically encased in soot before it's able to activate. It could just get like instantly clogged, kind of thing. I've seen that happen. Uh, Now, it's not that the smoke detector missed the alarm. It was like the 11th smoke detector just didn't go into alarm because it was a pretty bad fire. There's also issues with cold smoke. Uh, of course, heat rises, smoke rises. Uh, when the smoke rises and fills an area from wall to wall, from floor to ceiling, uh, the actual act of the smoke filling the area can cause the smoke to cool because the smoke can become an insulator and the uh, smoke closest to the ceiling can get cool and start to drop. Right. And so you could have a whole bunch of smoke, but nothing right up at the ceiling. It could stratify. We could lose that smoke buoyancy, and so we could have a whole bunch of smoke in the room, and it could be trapped on a layer below a layer of cold air, keeping it from the ceiling. It does happen, especially when in areas that has zero airflow. If we have a little bit of airflow happening to stir things up, we tend to be able to avoid that. Right? It's not hugely common, but it is a known factor. Other limitations we have to worry about is, well, they can only cover so much area. A smoke detector is probably not going to provide early warning of a fire developing on another level of a building, right? That's reasonable. Like there's floors and ceilings in the way. Yeah, the smoke's not going to get there. So put them on every level of the building. Well, we just looked at the installation requirements. That's totally covered. Uh, the other thing is, uh, if the doors are closed, well, smoke can't get through a door. It can get under the door and around the door, but not. If you have the doors closed, then you're going to have uh, breaks in the ability to sense. So detectors located on both sides of doors that are kept closed, you kind of need to do that. But again, following the building code requirements where the smokes need to be installed, that generally covers it. So our smoke detectors are power consuming devices, which means that there is a limit to how many smoke detectors we can put on a zone, because we can only consume so much power from that zone before we don't have enough power left to make the other smoke detectors function. Uh, the typical maximum number that I've seen is kind of around 30 to 40 smoke detectors, which usually you think, oh, that's not an issue. That's a lot of devices. But when you get into hospitals, yeah, you can have 50 and 60 in a zone without really pushing it. So you might have to uh, come up with other options. We might need to add power by using what's called four-wire smokes. We might have to add 24 volts to the smokes to allow them to run, especially with older panels. Not all circuits on older panels are actually capable of handling smokes. They might not all be smoke-capable zones. Uh, Anything made in the last 25 years, not an issue. But there, there's still a lot of panels from the 90s out there, so that could be an issue. But if we have a lot of smoke detectors on a zone, we might be exceeding the uh, power capacity of that initiating zone for it to function, especially if we have a lot of relay bases, because the relay base takes a little bit more power as well. So we might have to use four-wire smokes with the relay bases to make it all work properly. Unlike our manual stations and heat detectors, because those are non-power consuming devices, they are mechanical in nature, so we can put as many as we want on the zone. Not an issue. We can add pull stations and heat detectors to a smoke detector zone, no problem at all. But we also have to be careful that the smoke detector, the actual smoke detector, conforms to the panel requirements. It has to be officially listed as being compatible with the control unit. And so every control unit out there in the installation manual documents, all that stuff, and you can usually find them just by shaking the Google a little bit. There is a list of approved detectors. And if the detector is not on that list, you cannot install it. It might work just fine, but it might not work just fine in every situation. Wiring is critically important because this is the first time we're dealing with a polarity sensitive device. Positive and negative matters. They're also directionally sensitive the vast majority of the time. So the in and out matters. Putting the wires from the panel to the in and then out to the next device. And that matters. It's usually going to work even if we have the ins and outs messed up. It'll work under alarm, but it might not work properly under trouble. If it goes to initiate a trouble on the circuit, it's going to do that by opening up the wiring inside the device and killing the uh, the downstream, right? Gets rid of that end of line, we get the open circuit trouble. Well, if it's wired backwards, as soon as it opens to do that, the device powers down and then it comes back up because it's lost power and so it's resetting, and you could have a lot of trouble figuring out what's going on. So it might not work reliably in all situations if the in and out is not properly followed. Correct polarity as well. It might work on reverse polarity, but it will not work reliably on reverse polarity. Just installing it correctly the first time, and you're good. So our four-wire smoke detector, which I briefly mentioned, we use them in older panels which do not have initiating circuits that are capable of using smoke detectors. We also use them if we need to run a lot of relay bases, or if we need to just put in a very large number of smoke detectors. We might have to use four-wire smoke detectors. We might be able to avoid putting four-wire smoke detectors in the entire zone. Maybe the second half gets the four-wire smoke detectors. The first half, we're fine with two-wire smoke detectors, just pulling power off of the initiating circuit. Right? It'll depend on the nature of the system. But the four-wire smoke detectors, there's two separate circuits there. We have our initiating zone, and we have a separate 24-volt DC power supply. That power supply is coming directly from the fire alarm panel. And when you hit the reset button on the panel, it de-energizes that 24 volts. Because the only way you can reset a smoke is to kill the power to it. Because a smoke activates and it electronically latches in alarm. You hit the reset button and it goes away, which is why you never reset a panel right away if something goes into alarm, even if it's a false alarm, because you need to be able to wander around the zone and find the solid red light, because that's the smoke detector that's gone into alarm. If we do not provide that 24-volt power to the smoke detector, it is obviously not going to work. So we need to make sure that we have the 24 volts, and we're going to accomplish that by using an end-of-line relay. The end-of-line relay is just a coil that gets powered by the 24 volt. This is after the last of the devices, and it energizes a contact, right? It's a normally open contact, so it closes when it's energized. And we put that contact in series with the end-of-line device on the zone. So if we lose the 24 volt, we get the open circuit trouble. When we have the 24 volt DC going to the four-wire smokes, we're going to be able to get the end line on the initiating zone, and it's going to work. And there is the wiring diagram. Okay, so we can see that the blue and maroon, maybe burgundy, is the 24 volt power. It goes to the end of line relay. It goes onto the coil. Then we have the red black that goes, that's the initiating zone that goes to all the smoke detectors. It might be going to heats and pulls as well. That is fine. And you'll see that on these devices, the initiating zone is directionally sensitive, right? The positive goes in on the left and out on the right, in on the left and out on the right. The negative is not directionally sensitive, just the positive. And so we can see we have 24 volt power, and it's working. So the end of line relay coil is energized, so that contact is closed, and so we get our end of line uh, resistor working, and so we have our supervisory current. All is right in the world. When we go to connect in the panels tend to have a whole bunch of 24-volt options for uh, supplying power to devices. We have resettable and non-resettable 24 volts. And that's exactly what it says on the tin. When you hit the reset button, we kill the power to the resettable 24 volt. The 24 volt non-resettable or possibly non-labeled, when you hit the reset, nothing happens. That 24 volt just keeps going. So, and there are times that we need to use that to power things like our annunciator. We don't want to kill power to the annunciator every time we reset the panel. We want that on constant power. Right? There are other times that we use the non-resettable. If we need 24 volts to power things, like sounder bases. They're also referred to as audible bases. A sounder base makes the noise when the fire alarm system is an alarm. Uh, we use these in sleeping areas instead of using smoke alarms. If we use a smoke detector with a sounder base, when that detector activates, it's going to make the noise exactly like a smoke alarm does. Right? So if we install these, we don't have to install smoke alarms. Useful in condominiums, apartments, stuff like that, because you can drastically reduce the cost, and especially the maintenance cost, by combining the two together. Right? We're not required, Group C occupancy, we're not required to have a smoke detector in the apartment. We are required to have a smoke alarm by the building code. But if we put in smoke detectors with sounder bases, that covers the smoke alarm requirement, and it lets us know if there's a smoke situation inside the unit. So yeah, it gives us an overall safer environment. So we use sounder bases. Not shown on here is the interconnection wire, right? Here we see two separate sounder bases. The only time these bases make noise is when that smoke detector goes into alarm. Right? It does not make an audible noise when any fire alarm zone activates. If you pull a pull station 3 floors down, nothing's going to happen to these sounder bases. It's only in the immediate area, just like a smoke alarm. But there is a third wire you can add, the interconnection wire, just like we do on smoke alarms. So if we have we have multiple of these devices in an apartment, we can interconnect them just like we do with smoke alarms. And so all the sounder bases in that apartment will activate if one of them goes into alarm. So we can interconnect all this stuff. The audible bases do not need to be de-energized to reset. So we use the non-resettable source because the device itself, the smoke detector itself is pulling power from the zone just like a normal smoke detector does. We've got to be careful with that though, because certain manufacturers sounder bases use require resettable power. Certain manufacturers sounder bases require non-resettable power. It varies by manufacturer on how they're accomplishing it. So always check the documentation so that you're terminating it properly. One of the other things we can do with smoke detectors is use something called status change confirmation. I've only ever seen it once, and I really do not like it. Uh, the concept is great, right? It's for reducing false alarms. If we have areas that we have a lot of false alarms, we can change that zone to being a status change confirmation. Of course, we have to provide written documentation. We have to be able to provide to the authority having jurisdiction. Yeah, we've had this many false alarms this month. We want status change confirmation, and they will decide whether or not to allow you to do it. Among the criteria they look at is, will it reduce the false alarms? Is the area being protected by the smoke detector subject to the request for confirmation? Does it contain a light fire alert? Is it concrete and drywall and things like that, or is it wood paneling, wall to wall shag carpet? So if the area is extra burny, lots of things that are quite flammable, they're probably going to say no, because the status change confirmation, it delays the inevitable. The other thing is only smoke detectors can be subject to the alarm confirmation, the status change confirmation. So if we have heats and pulls on the zone, we have to remove them from that zone. Right, so we have to rearrange it. And again, permission is only provided by the authority having jurisdiction. Because what happens is the panel gets reconfigured for status change confirmation. So you put smoke to a smoke detector, the smoke detector goes, oh, there's smoke. And it tells the panel, oh, we got smoke, right? Because it's gone into alarm. The panel goes, well, I'm not convinced. I'm going to wait 30 seconds and then reset you and see what you say. Right, so the panel will wait 30 seconds. It will reset the circuit and see if it's still in alarm, right? Because the smoke detector latches, we reset the power, so it's unlatched, and if it goes back into alarm, then it's going to set off the bells. It's going to call the fire department, all that stuff. So we've added a 30-second delay in activating the fire alarm system. Okay, yes, it's going to reduce false alarms, but that's an additional 30 seconds before the bells go off, before the signal even gets to the fire department. So it's going to be a slower response time. Smoke detectors are great for early detection, and as such, they are fantastic for life safety. If we add 30 seconds, that is a very long time in a fire situation. With a fire situation, it usually happens pretty fast, right? Seconds count in a fire, so it could be too dangerous to add smoke status change confirmation, and so not recommended. When I did the fire alarm upgrade at West Lincoln Memorial Hospital, all the smokes in the patient rooms had status change confirmation, which kind of makes sense because when they upgraded the fire alarm system the previous time, which was like 1993 or something like that, uh, smoking was still allowed in certain parts of hospitals. It was a whole other world back then. And the number of patients that would just light up a cigarette in a room was insane. It's not that common now, right? It's, on a larger hospital, it's probably only once or twice a month. But it used to be like near constant. And so they put in status change confirmation to delay those alarms. And so we're doing the upgrades to the system and all this. And we replaced the system and everything went back in a status change confirmation because The drawings said that we are to match the existing programming, right? So that got reconfigured. Uh, as part of the upgrades and everything that was being done to the building, the maternity ward was closed down for 6 weeks because we had to completely redo the maternity ward because it was terrifying how outdated some of that stuff was. And then it got reopened, and as part of the reopening, the configuration of the ward had changed. Things had been moved around and all this, and so they had staff training. Great idea. And of course, one of the things they were doing was staff training for emergencies. Great idea. Let's do the training. And so the fire alarm, and they decided to do, among other things, they did training for what if there's, a fire in one of the recovery rooms in maternity, right? So you got mom and new baby right there. What if a fire breaks out? What do we do? Right? They have their procedures, but they wanted to test it. And so the maintenance manager borrowed a can of smoke from me, and they went up to test it, and they couldn't get the smoke detector to activate. The smoke detector worked. We'd verified it the week before. They could not get the smoke detector to activate because of the status change confirmation. They actually tried, and I was not happy they tried this because it's a bad idea. They lit some paper on fire and held it under the smoke detector to see if they could get it to activate. And they were having trouble getting the smoke detector to activate. It took them like 6 tries or something like that to get that smoke detector to activate. And they actually caused a fire. Like they had legit fire in the room right near the smoke detector, and they're having trouble getting it to trigger because of the status change confirmation. So I am very much not a fan of status change confirmation. Uh, I think you just live with the false alarms or do modifications to your building or your procedures to reduce the false alarms. Whatever way is going to work out for you, but status change confirmation, I do not like. Moving on from our two types of smoke detectors, let's go back into the world of heat detectors. Linear heat detectors. I've worked with this stuff a couple times. It's pretty cool. You've got to be really careful of it. It comes in a roll, 100-meter roll or whatever it is, and you can use the entire thing in one shot. And it is a cable that can detect heat anywhere along its length. So if you have a 100-meter run of this stuff, that's a 100-meter long heat detector. It is really cool stuff. Uh, we use it. Uh, we use it to protect very large, complicated areas. It, we can because we can mount it directly to racking in a warehouse. Right? So we can protect like each bay where you would put skids. We could put it in there. I've used it mostly in aircraft hangars as additional detection, and it just gets it's been tie wrapped just to the sprinkler lines, and also in warehousing, uh, especially in uh, cold storage warehousing. Right, the entire building's like 15 below zero. You can't use smoke detectors; way too cold. Linear heat detection is a great option. And so anywhere that you run sprinklers, you run linear heat detection because it's a lot more sensitive than the sprinkler heads. So uh, you can catch the fire earlier. Right? This is not so much for life safety in these applications. This is for building safety, right? Protecting the building and its contents versus the people, right? A cold storage warehouse, it might be 100,000 square feet and they might have 6 employees. Right? But the stuff inside is worth quite a lot of money. Same thing with an aircraft hangar. Uh, you could have an aircraft hangar that's big enough to hold, 2 passenger jets, and you've got like 3 or 4 people working in there sometimes, right? Very, very light uh, people load, but very, very large amounts of money in there, especially if you have a stack of 6 or 8 Rolls-Royce turbine engines for 767s in the corner for engine changes during maintenance. And each one of those, a seven, refurbished Rolls-Royce turbine engine for a 767 10 years ago was worth about $7 million. Right? We're talking about a lot of money. So going through the expense of putting in things like linear heat detection, totally worth it. Right? So they are odd. It's a very they're it's a very, very fancy cable. The stuff is not cheap and is not easy to work with. It is steel conductors, not aluminum, not copper. They actually use steel because they want it to be very, very rigid because we twist them together to impose a spring pressure between them, and then wrap them with protective tape and put on an outer jacket that is suitable for the environment, right, to keep it all protected. But on the conductors, there's the protective tape and all that, but that's a heat sensitive polymer. If you heat up the cable, that polymer gets a little bit melty, and the because the steel conductors are under spring tension, they'll touch and it'll set off the alarm. When it cools back down, it sorts itself out. Right? It's pretty cool. If you put it under too much heat, yeah, it's going to fail. You might have to cut out and replace a section, but it works really, really well. But insulation is very, very important because it's spring loaded. If you're attaching it with tie wraps and you pull the tie wrap too tight, alarm. You got to be very, very careful when you're installing it, but it is really, really cool. Uh, there's the low budget way of installing it and the expensive way of installing it. And the difference is, on the left of that picture there, the optional distance locating module. I haven't installed one of those yet. But if you're trying to protect something very, very long, like a conveyor system, and you want to know if there's a fire condition exactly where it is, well, you can use a distance locating module, and it can tell the distance based on the resistance once it activates, because that wire has a known resistance, and it'll give you the distance in feet and meters. It's the same concept as the wire distance measurers, right? The wire length measurers. You take a spool of wire and you attach one end on each, and you tell it what gauge of the wire it is, and it'll tell you how long it is, right? Same kind of thing. And then to that, we run out normal wiring out to the area, and then we put in strain relief connectors, and then we just run it to wherever we need. And at the other end, strain relief connection and an end of line resistor. And then we have to make sure that it's mounted and supported properly. Right? It can be mounted along a messenger wire. It can just be tie wrapped to things. There's all sorts of different ways of mounting it, but we have to be careful that we do install it properly. And it will trigger anywhere along its length, which is fantastic because we can get a very large amount of coverage. And usually we don't really care where along its length it's activated. We just want to know that it is activated. And that's enough. So we use the much cheaper uh, module and attach it to the fire alarm control panel. Of course, those modules require 24 volts. We have to put 24-volt from the panel to the module as well. Uh, and every time I've installed these, I put these modules right beside the panel because if you look at the leader wires, minimum of 18 gauge and a maximum distance of 2.4 kilometers. We can go a really, really, really long way with this stuff. Right, so I just slap them right beside the panel, then run two wires out to where I'm going to start the linear heat detection and swap it over there. That way, everything is right at the panel and very easy to work on in case there's any issues. And it can also be done as a Class A configuration, right? We can bring the whole thing back as a loop and tie it back into the uh, linear heat detector module and uh, go from there, right? Depending on what they want to do. I haven't done that type of installation yet. I've only ever done it as a Class B. But this is the kind of thing that we can do. We can run that thermal cable in the racking. Uh, on pre-action systems is usually where I'm seeing it. I've installed it for pre-action systems. We learned about pre-action systems in level 2, and I've learned about them. I've installed them on foam systems and aircraft hangars. Right. So, we go from the panel to the module, then the module out to the location. So we run the cable to wherever, and then we hit the end, and then we go to the end of line. It might be right there. We might have to bring it down the wall so that's mounted at the correct height, or we could go all the way back and right back to the module. It depends on the application. But we can do the same thing with fiber optics. I haven't gotten to play with this stuff yet, but it is really cool because well, it's pretty robust. And instead of relying on spring tension of wires, we're actually looking at temperatures. We actually detecting the temperature, and we can record that as a continuous profile, which also lets us get an idea of how big the fire is based on how hot the area is and how big the area is and which direction the fire is moving. Oh, it's going this way down the fiber optic cable. It's going this way down the fiber optic cable. So we can actually use to get very, very accurate information about the fire condition. Very, very high technology, very, very not cheap. I haven't seen it yet. I might not ever get to see it, but it's one of the few systems I haven't gotten to see yet, so I'm still hoping. Take a giant leap back in technology. Air duct detectors. We call them duct smokes, right? Because they go in the ductwork and they're smokes. Right? And we use them to sense the smoke, the products of combustion inside the ductwork. That smoke could be coming from different sources. It could be coming from the return air. It could be coming from makeup air from the outside, or it could be coming from inside the air handling unit, the actual overheated motors and drive belts. That's where we could that's the three locations we could be getting it from. Usually it's on the return air, right? We're picking up smoke from somewhere else. We're sending it back through the air handling unit and inside. Unless, of course, there's a giant fire next door and we're running 100% fresh air, then we totally could be sucking it in from outside. So This depends on the nature of the fire. There's three different designs there. Every manufacturer has a different design. The system sensor one, which is the one that I think that's a system sensor there. That the one that we're seeing the exploded view of. They are everywhere. Because this is also what we're putting in residential. Because you can get the I think it's the SL2000 duct smoke. You can run it off of 24 volt DC from the panel. You can run it off of 24 volt AC. You can run it off 120 volt. Right. And if you need to put a duct smoke detector in your furnace in the house, right, in the air handling unit in the house, because you have two units, right? You split the house into a duplex, and so we have to keep the smoke from traveling from one to the other. So if it activates, it shuts down the furnace. Uh, we can do that all with the one unit. It's pretty cool what the stuff can do. But depending on your application, vast majority of the time, uh, you're using the smoke detectors that are provided by the manufacturer of the fire alarm system. There are exceptions, and we're going to be start talking about those in Module 8 when we start talking about ancillary devices, because there's a whole nightmare that has come up now with duct smokes. But for right now, we're going to worry about the old school application of duct smokes, which is still valid and still happening, not all the stuff that they're adding on top. We can use photoelectric or ionization. 99.9 times out of 100, it's going to be photoelectric. And we put them in the heating, ventilation, and air conditioning. Duct systems. They are not a replacement for open area protection. Our smoke detectors out in the patient rooms and hallways and all that still have to go in. There's not a replacement for that. It's only to detect smoke inside the ductwork. And they do not like the cold. Just like any smoke detectors, they do not like the cold, which is a huge annoyance because so often we have to put them up on the roof because the ductwork's being run along the roof. It's really frustrating because now we have to put an insulated box in. And most of the manufacturers say that, oh yeah, you use this insulated box, it'll get the waste heat from the ductwork and it'll work just fine. Yeah, rarely happens. Often I end up putting in a little like 20 watt, maybe a 40 or 50-watt heater. Uh, run it as run it. They run on 24 volt DC. Run it right off the fire alarm panel, the non-resettable power. It's self-thermostating, so it only turns on when it's cold, and it just keeps the duct smoke detector inside its enclosure from getting cold and damp and failing. The other thing we have to worry about is airflow rating. Some of this ductwork is really, really high airflow, and it can be too windy for them to work properly. So we might have to put in lots of extras. Right. They've changed where they go over the years. Not all engineers have gotten that memo because, it's only been 20 plus years since they changed this. More than 20 years because it changed before I started doing firearm. So it's been a very long time. We do not put duct smokes in the return air. Because the return air is just coming from the area that is being served by the air handling unit, and we have area protection down there. We have heats and smokes and all that stuff down in that area. So we don't care about the return air. We only care about the supply air. The goal is to not put smoke into the floor areas. That's what we're trying to stop. So we put our smoke detector, our duct smoke, downstream of all filters, cooling coils, heating coils, supply fans. We put them downstream. The downside, of course, is often the mechanical engineers don't think about this. And we have an air handling unit on the roof, and the ductwork comes straight down and then branches off two or three or four ways immediately. And so we don't have any space to put the duct smoke because we need a fairly long straight length of ductwork. Uh, the rule is generally 6 duct widths. Okay, so if it's a 2 foot wide duct, we need to be 12 feet downstream of any bend or turn or change in size or fan or anything like that. So getting that kind of distance can be difficult. So before we start to split, right? So the on the left there, that is the ideal insulation. On the right is what you're more likely to find. If I can't get uh, a clean insulation location before it starts to split off everywhere, I have to make sure I protect every single branch. Right? I can't just protect half of them and call it good enough. I protect every single branch. Right? And I've done that on the left with the one duct smoke because all the air has gone through this duct smoke before it hits the floor areas. It's also being done here, except it's taking 4 times more devices. So now it's 4 times more expensive to install and vary in region. So we have to make sure that we have our correct coverage. And then if we have high airflow, we need to put in more because the air is just traveling by too fast to be able to pick it up. And if we have very large ductwork, we have to put in more because we can only cover so much area, right? If we're at air velocity greater than 1.5 meters per second, we have to install a duct smoke for every meter and a half squared of cross-sectional duct area. Usually this isn't an issue. Most buildings, they've gone towards smaller air handling units and more of them, so you can have more detailed control. But large facilities like colleges, universities, large apartment buildings, hospitals, they go for big air handling units because there's less maintenance. The air handling unit itself is bigger, but there's fewer of them. And so you could end up having to install a lot of duct smokes. I've done a air handling unit. This is a number of years ago, and if I had a picture of it, it's long gone. Uh, it was big enough that we had to put 8 duct smokes in the same spot to get enough coverage. It was ridiculous. Took a long time to install and wire, but it did look pretty cool one time. We want to install the duct smoke so that we're getting a representative sample of the airstream. So we're going to put it through the middle of the ductwork, and we're going to make sure that it's rigidly mounted because we don't want the air sampling tubes to bend under the wind. Generally speaking, if the duct is 3 feet wider, 3 feet or more wide, we put the air sampling tube right through to the other end so it can get supported by the other side of the ductwork, and we just put the cap on it. Uh, again, depends on the insulation, and then it's really easy to figure out because the air sampling tube has holes in it for actual sampling, and you just point them into the wind. Perfect. And then you have a short tube that just pokes into the ductwork like we see here, and it's open at the end, and that the air flowing by that actually sucks the air through the duct smoke detector. It's the Venturi principle. Works pretty cool. Yeah. So we need to have straight section with laminar airflow because every time the air hits a corner, it gets very turbulent, and we're not going to be able to detect it properly. So we need clean airflow. We put them in a straight section of duct, and we have to be downstream of all of bends, right? Ideally, we want to be 6 duct widths downstream, but we also want to be at least 1 duct width upstream of any corner or T or anything like that, because that also causes, right, that corner is going to cause disturbances in the airflow, and it could be enough that it disrupts the airflow where we have the smoke detector. So we want to be a little bit upstream as well. So it can be frustrating trying to find good locations, and then you have to argue with the general contractor. It's like, yeah, the duct smoke has to go right here. You need to put in a hatch, and they don't want to put in hatches and all that stuff. We talked last week about differential pressures through pipes and all that, putting in sealing compound. Extra important with duct smokes because we're on purpose running air through it. So the whole thing needs to be properly sealed. It's properly sealed from the factory, the way it's designed. Right? We have to make sure that we don't modify anything, which is why you'll see that all the connections are in a separate part of the enclosure away from the actual airflow portion because everything needs to be sealed. If we have the cover off of this thing or not screwed down properly, we're not going to get proper airflow and it's not going to work properly. And one of the things we have to do for verification to make sure it's actually working properly is we have to open the unit up while the air handling unit is running, and we have to do a pressure test. We use a manometer to make sure that we have a proper differential pressure between the intake and the exhaust tubes, and that it's not too high or too low. So it can be a little bit annoying to work with. Where do we install them? Well, an air handling system is going to be designed to prevent the circulation of smoke upon a signal from a duct type smoke detector if the air handling system serves more than one story, more than one suite in a story, more than one fire compartment, or if it is not provided with fire dampers. Right. So if we've got one air handling unit that's doing all 4 floors, the giant air handling units that we see in colleges, universities, and hospitals, and it's going to get duct smoke detectors because, well, if it starts to throw smoke, it's going to be throwing smoke all over the place, and we're not going to know where the fire's coming from. Right, so we're going to want to shut it down. If we're serving more than one suite, that could be office suites, it could be apartments, anything like that. If we're serving more than one suite, we have to be able to shut it down. So we're going to have a duct smoke detector, and this air handling unit is going to shut down on a signal from directly from the duct smoke detector because you can get relays in them, or it'll shut down right from the fire alarm control panel via a relay. And we'll be talking about that again in Module 8. Then if we have more than one smoke compartment, right? If we've got more than one zone being served by the air handling unit, right? If we've got well, oh, words got hard there for a moment. Right? If we've got 2 wings, right, the north wing and the west wing uh, of a building, and each of them exceeds the maximum allowable area limit that we saw back in two classes ago. Right, there's maximum amount of area they can have in a fire zone. If we're more than that, then we're gonna have to put in a duct smoke detector because again, we're not gonna know where the smoke is coming from. And then if we have no fire dampers, uh, usually we have fire dampers built in, right? Nothing to do with us. The sheet metal mechanics are installing them and as needed, but in small buildings, we might not be required to have them. Then, if there is no fire dampers provided, then we have to put in the duct detector. And this is what we see in small residential. So we have our sampling tubes. We can tell that this one here is the sampling tube. This one is the Venturi tube, right? The air flowing across this uh, sucks the air this way, so the air is getting sucked in through the sampling holes and across the actual head and then out. So we point the holes into the wind. If it proceeds, if we run it straight through, then we have to cap the end and make sure that it's properly sealed. Right? And so they come with, rubber stoppers. Can't really call them corks because they're made of rubber that you jam into the end and then you seal around it. And that's what the foil tape is for. Just tape everything up and we're all good. And then there's our manometer test, right? We've got point 0.2 on that, and that's usually measured in inches of water column, I think is the usual measurement. It's because, well, instrumentation. They're measuring it or whatever. So this is a system sensor detector, right? Dust smoke detector, right? And we can see all our connections are in here, and it's a completely separate compartment where the wires run through. That is fully sealed so that we don't have any air getting out from in here. And it even has a set of contacts. If you pull the cover, we get a trouble on it. Perfect. There are additional requirements for duct smokes. They have to be inspected and tested to confirm the operability, including the following functions. It has to be rated for the air duct size and correctly installed, and the differential pressure has to be within the manufacturer's specifications. The other thing that we end up doing is putting in our remote LEDs because the vast majority of the time, these duct smokes are up in a ceiling somewhere. You can't see them from the ground, and you have a device that you can't see from the ground, we need a remote indicator. Even in mechanical rooms, we often need to put remote LEDs in because the duct smoke could be so high up and it could be so much piping and duct work and all that stuff all up there. You might not be able to see it from the ground. You might have arrows that people have written over the years on how to find it. So we have to put in remote LEDs. And it has to be installed so that the visual indicator, right, the remote LED, is clearly visible from the direction of travel to the protected area. Right, so we can't tuck this remote LED in a closet in the very back of the area. It has to be in the direction of travel. Right, so we have to be able to find it. easily, because this is going to tell us which device has got into alarm. We're going to know that from zoning, right? Air handling unit number 1 is going to have its own zone. The duct smokes on air handling unit 1 is going to have its own zone on the panel. Nice and easy if you have one duct smoke on air handling unit 1. But if you end up having 4 or 8 or 12 or 20, well, which one is it? We're going to want to be able to find that remote LED so that we can figure out which device has got into alarm. Air sampling detectors. Very fancy, quite fun to install, really, really finicky to configure properly to get them working. They can be a giant nightmare. They're fun to install because, well, they get installed using blaze pipe. You know, the that orange plastic sprinkler piping that you see sometimes. It gets installed, but it gets installed by us, not the sprinkler fitters. And so, well, it's a fun change. These things are really, really sensitive, and we can detect the smoke from very, very specific locations because they are air sampling. They have a fan built into them. They are sucking air from whatever environment they need to and uh, running it through the smoke detector mechanism inside the units. These can be used in place of open area detection. Like we can put a giant piping system in and use it to protect the open areas. Not common because these things are very expensive. We typically use them in very, very specialized application, mostly data processing sensors, the data centers. Because what we'll do with these, I call them Vestas because that's the major manufacturer of them, is we'll actually put sampling tubes right into the server cabinets. So we can pick up anything going on really, really quickly. Uh, the other thing we can do is we can set different thresholds, right? So there's a certain parts per million that it's determined to be fire, but we can set other signals at lower thresholds. So, you know, maybe at, let's say if it's 10 parts per million is deemed to be fire, maybe at 3 parts per million, we send a signal through the building management system to say, yeah, someone's got to come and have a look, right? Something like that. We can do all sorts of fun things with this. So they're great for data processing centers, clean rooms, right, so the high paranoia areas, but also the very difficult to reach areas. One of the places that I've been installing them every once in a while is in elevator shafts and electrical bolts because the piping and the sampling tubes and the holes and all that gets installed in the area, but the actual VESDA unit, right, the air sampling unit, can be installed in a different location. We just run the piping over to it. It's sealed piping. We're not getting any air in from anywhere else. So we can put it elsewhere. So instead of having to get access to the top of the elevator shaft, we can put a VESDA in and read it from outside. Great in theory, but problematic because an elevator shaft is, they're pretty small. There's not a lot of space around the elevator car. And so when you run a elevator car from the bottom floor to the top floor, and if it runs non-stop, you're actually going to pressurize the air at the top because it's a piston, right? It's a leaky piston because there is airspace around the side, but it's still going to pressurize, and we can overpressure the air sampling uh, detector, and we can cause troubles and faults on it. So it can be problematic in places like elevator shafts. As many Vestas as I've installed for elevator shafts, I have gone in and removed the same number from well those and other elevator shafts. Right? I am almost at zero for installed removed. Uh, I've probably installed 30 Vestas systems at this point, and I think I've removed like 28 somewhere around there. It's because too many troubles with them. Right? Now, I think a lot of that is they're not properly configured. Um, and so instead of just getting them configured properly, they're just removing them. In the early days of air sampling detectors coming out on the market, uh, special technicians would come in and do the configurations. Like Vesda trained technicians would come in and do uh, the commissioning on these things and get them dialed in properly, and those things worked great. When they stopped doing that, it was just normal fire alarm technicians who might not have much or any specialized training on Vesdas, and they're just reading the instruction manual. I don't think it's sufficient, right? So there can be issues with it. The only place that I've installed them and I have not gotten any complaints on is in electrical bolts because well, we're not pressurizing and depressurizing an electrical volt, right? It's just sitting there. And it's great because now you don't have to go into the high voltage area and you still have your smoke detection, right? So absolutely delightful option. I quite like doing those ones. Right, so we have some pretty significant limitations with these. Uh, there's not a whole bunch said in S524, the standard for the installation of fire alarm systems, about how to install the air sampling detectors. They mostly leave it up to the manufacturer. Uh, the big thing, big thing is the pipe work. The pipe network has to be airtight, permanently fixed, and conspicuously labeled. Pardon me, I have the hiccups here. Has to be conspicuously labeled as smoke detector sampling pipe because, well, it can get painted and then you might not know what it is at all. But if it's not painted because it's blaze pipe, it might get mistaken for sprinkler pipe, which is going to cause issues. Right? You also have to have warning signs to not disturb or alter the sampling pipe, and we have to put those warning signs, they're stickers, every time we change direction. So at each elbow, on each side of a wall or floor, anytime we go through anything, we have to put the warnings on. And other than that, every 6 meters, we have to put warnings on. We have to put warnings on everywhere to keep people from messing with it because that entirety of that uh, tubing network is part of that device. It's part of the fire alarm system, right? And people can be slow to recognize that. We also install our own holes, right? You get to drill the holes in yourself, and you get instructions on exactly what size of holes and how far apart and all that. And the more holes you have, the higher the fan speed you need to have, and all that stuff for uh, configuration. One of the issues with the elevator shaft, a one-car elevator shaft really only needs one sampling hole, and so it's really susceptible to pressure changes and to clogs. So works just like any other smoke detector. Right? They are only available as a photoelectric. That's all they designed it for. But we're using a fan to actively pull the smoke in, and then we use our uh, light projectors and receivers. But we're also using two different wavelengths at this point. we use a blue light and an infrared. So we're working at both ends of the visible spectrum. Like yes, infrared is technically outside the visible spectrum, but only just, right? So we're looking at two different wavelengths because we're trying to be very, very specific, and we're looking at some pretty extreme sensitivities here. For large open area protection, beam detectors are the way to go. They're a lot of fun to install, so long as you plan things out properly, and you always need to bring 24 volt to them. Right, we got going to have the initiating zone and 24 volt because they require a little bit of power. Some of them have two parts. They have a transmitter and a receiver. The modern ones, like the newest ones, except for the really long range ones, uh, are it's a combined transmitter receiver, and we just put a reflector at the other end. Because all we're doing is we're shining light, uh, typically in the infrared, right? So you can't see it. We shine light right across the area, and then it bounces back. And so long as we're seeing the correct amount of light, there's no alarm. We have to configure them as well. We get to aim them and all that stuff. Some of them have lasers built in for aiming them. It can be pretty fun to work with. Again, documentation is important. Uh, we've got to be careful where we install these. A photoelectric smoke detector, the light sensing, the light chamber, and all that stuff is inside the unit. This is the same concept, but it's outside, right? So we have to be careful where we mount them. We don't want to put them in direct sunlight because we're going to baffle it. Uh, we can put them in places like gymnasiums. You know, there's basketballs flying through the air all the time. That's actually not an issue. They don't react so quickly that they'll go into alarm because of a basketball going through. And if you just 100% cover the beams detector, it's not going to go into alarm. It's going to go trouble, right? Because it's smart enough to figure that out. At the same time, though, if you're putting these into somewhere like a gymnasium, you need to use a really, really good cage because it's just a target begging to be bombarded by projectiles. Right. Well, they're great for very high areas, large open areas, or irregular ceiling configurations. So we've got all sorts of, architectural wonderments like in atriums and stuff like that, ballrooms. Beam detectors are absolutely the way to go. Uh, we have to install them in accordance with manufacturer's instructions, of course, and that's the big one. And we install them near the ceiling and free of obstructions, right? But such that smoke and other fire-related gases will pass through the beam as they rise to the ceiling. So we're not putting them right up at the ceiling. We're putting them a little bit down. And the manufacturer says exactly where they have to go, how high up they have to go, and all that, usually expressed as a percentage of the ceiling height. So this is one of the things you absolutely need to have the shop drawings on these things before you start roughing in. You know how many wires and where. Some of them have base units that get installed down at floor level for aiming and control and maintenance. Some of them don't. They are all completely different. I have not yet installed two identical uh, beam detectors. I've installed six beam detectors, I think, at this point. Uh, and I have, well, no, sorry, six jobs I've installed beam detectors. I've installed multiples on jobs, so at this point, I've installed six different models of beam detectors. Every time I get them, they're different. Right? So you got to really make sure that you know what you're doing. Otherwise, you can have some pretty extreme troubles. Right? They are very sensitive. Halogen lights also mess them up huge. Not really an issue now because the world has gone LED, but sunlight. Right? So if we've got large windows, skylights, anything like that, we want to make sure that we do not have direct light going into the transceiver. So maybe instead of installing them on the north wall, we install them on the south wall, right? So that we never have uh, direct line of sight to the sun. Don't put them through glass, right? Yes, it can read through glass to a point, but we're working on the reflection principle with a single end beam detector, which is most of the time. And a pane of glass perpendicular to the line of sight is going to refract and reflect the light. Think back to physics, and it's going to cause issues. And the beam detector is going to get confused, and it's going to start throwing troubles or random alarms. The uh, the nice thing with beam detectors is because they are not mounted right up at the ceiling, uh, cold smoke becomes less of an issue, right? When we're talking about large areas, stratification of the smoke becomes much more significant. And so by mounting them lower, we get to skip that problem entirely. But like a standard smoke detector, like not an extra range or anything like that. A standard smoke detector will go about 330 feet, round about 100 meters without even trying. The only thing we have to do is put a larger reflector on. So instead, like a standard reflector is about 8.5 by 11 sheets, and the large reflector is just four of them. Right, and that's all that we have to do to get it to work to that kind of range. 100-meter long room is really big. Now, if we've got a 100-meter long room, it's probably going to be pretty wide as well. So we're not going to be putting in just one. We're going to be putting in more. So we could have two or three or four going across the width of the room. And if it's a really tall room, we might have to double stack them. We might have to put two different levels of beam detectors in. Manufacturers have all the say on this one, right? Because they've designed their system, they've done all the testing, they know exactly where it needs to be. Uh, but if we do have to run multiple devices because the room is so wide, right? Oh, yeah, we can put them. Sometimes we can put them like 100 meters apart, right? So we could have a really big room and only have to put in two or three of them. Any gymnasium that I've done, and I've done a couple of them at this point, the biggest one I put in three, and like that was a high school size gymnasium, like the size of gymnasium that you split in half for gym class kind of thing. We put in three of them. That was all that was needed. Right? So they can cover pretty big areas. And then, of course, if we have weirdly sloped ceilings, then we have to be careful with that as well, because again, we don't want to put them up into the dead spaces. We need to have permanent clear line of vision. Right? Working in gymnasiums and stuff like that with the fold up basketball nets, we have to make sure that they're not going to be obstructed at any time. And we want to stay away from reflective objects. We do not want reflective objects near the line of vision because that can mess things up as well. But they're quite fun to install. The verification of them, again, quite fun because to verify, you can't just throw smoke at it. You actually have to hold up pages of dots of with different intensity of dots to simulate how much smoke there is. So, it could be standing on the ground with a great big stick and a wall, a book of dots, stuff like that. The configuring of it can be really, really finicky, especially if the uh, control unit is in a different room, so you're out of line of sight. So you might have to aim it, and you've got an apprentice on the radio telling you, "Oh, you got to go to the left or to the right, up and down," and that can be difficult if the apprentice doesn't know the difference between left and right. It can get frustrating at times. The most fun I've had installing detectors is with flame detectors. I've done two jobs with flame detectors. The one I was a baby apprentice, uh, long time ago. We put in flame detectors in a canola oil testing laboratory because it was a laboratory, a federal building. They were doing it was a laboratory looking at different ways of extracting canola oil, right? Efficiencies and different ways of doing it and all that stuff. And of course, canola oil is flammable, especially when you're extracting it under pressure, all sorts of issues. So we had flame detectors on the fire alarm system, and we had flame detectors tied into the electrical panels. The electrical panels uh, that we installed to power, all the lab stuff was on a contactor, and that contactor, well, there was e-stops on it, but it was also the flame detector. So if you stood in the middle of the room and just flicked the Bic lighter, it would shut off all the power in the room. It was pretty cool. And then years later, I was all grown up and old. Uh, I got to do flame detectors for airplane hangars because they detect flame. Right? Flame is bad in somewhere like an aircraft hangar or a, flammable oil testing laboratory. So we use flame detectors. Uh, it's great because it provides large open area protection. You can't put a pile of smoke detectors or heat detectors on the roof of an aircraft hangar. It's not going to work right, especially since well, the one wall is all door. So anything that's relying on airflow is going to cause issues, and we want to detect it as quickly as possible. Again, the sheer cost of the equipment in there, and the fact that these aircraft are coming in, they're not empty of fuel. And if you have a large amount of jet fuel, that can be an issue. Jet fuel is not super burny; it's just kerosene. But you put flame to it, it's going to burn. And it's going to burn a lot for a long time, and that is bad. So we've got two different types. Uh, they are line of sight devices. Of course, they are flame detector. They have to be able to see the flame. Right? They detect the radiant energy that is emitted by a flame. Uh, and we've got two types. We've got ultraviolet and infrared. Right? So both ends of the visible spectrum. And then we've got the multi-spectrum ones that will do both. And it can kind of cover the entire range. These things are not cheap. We're talking 5 grand or more. And whether you use UV, IR, or multi-spectrum depends on the specific application. We can mount these outside. Right? I have seen them outside in at refineries because we can use them outside. There's a rain hat that you put on them to keep moisture off the lens, and that's about all you do. They are intrinsically safe. They are milled out of a solid billet of aluminum, incredibly tight tolerances, so they can be put in hazardous locations. All sorts of really cool stuff. Right. So we're looking at either the infrared or the ultraviolet range. right? So we're also going to be picking up across the visible band, right? So this is a very narrow range of wavelengths. Right? One of the reasons that we are detecting across the visible range is we want to be able to discriminate against non-fire, the false alarm sources. Right. So our UV and IR energy, it's emitted from both fire and non-fire sources. We do not want to get confused. We do not want misinterpretations. Uh, so we actually use algorithms and optical filters because flames flicker, right? And it's pretty predictable on how they flicker. And so we can use a fairly simple CPU to be able to figure out if it is a flickering flame or if it's just something else. Uh, because they're line of sight, it's very important that we mount them correctly. We do not want them looking up. We do not want them facing the horizon if they're outdoors. Typically, we want at least 30 degrees down. The ones I installed in the uh, aircraft hangar, we put them right up at the ceiling and we actually angled them down at about 45 degrees because we had to be able to catch directly below and then all the way out. Right? If we left them up pointing up any higher, then there would have been a very large dead spot near the wall, and everything gets stored near the wall in an aircraft hangar because that's where the planes don't go. So, uh, got to be careful. Right. So our ultraviolet flame detectors. Uh, this is what was this is what was installed in the aircraft hangars because very fast response time and uh, well, jet fuel puts out a lot of UV. Right, works great. Uh, the one aircraft hangar got 8 of these. The other one got 6, so that we could get all the coverage that we needed. The actual detection of the flame, if it's a large enough fire, it gets detected, well, while not instantly, as close to instantly as you can get. So if you take a garbage can and light it on fire, right? Well, the inside of a garbage can, that big of a fire will be detected effectively instantly at 200 feet away. Right? Very, very responsive. Uh, the Of course, the larger the fire, the faster it's going to respond. The closer it is, the faster it's going to respond because in its viewing angle, it's just going to take up more space. Uh, so there can be some delays, but it is still uh, pretty quick. Right, so we're using the low ultraviolet, just above the visible blue light, right? So we're looking at the actual emitted photons that are being detected, which photons travel in a straight line. Uh, and so it can identify a flame by that specific wavelength, right? It's a higher frequency, so got a shorter wavelength. Uh, Officially, the response time is 3 seconds for a 15 centimeter diameter gasoline fire at 3 meters. Right, a 15 centimeter gasoline fire is not that big. That's a 6 inch diameter. 6 inch? No, 400 is, yeah, about 6 inch diameter fire at 3 meters. And generally insensitive to sunlight and artificial light. Right, they're pretty good with that. The testing, them. Now, I tried so hard to convince the owners of the hangar to just empty the room and just light a bucket of fire in the middle and let it trigger, they wouldn't go for that. I asked, they laughed and said no. So you have to use a UV light source, but it has to be a approved UV light source. And so here is me. Oops, I just lost it. Here is me holding my ray gun. Of course, big smile because how great a day. I got to hit, like, I looked like Marvin the Martian with this thing. Uh, Great big battery and shooting out infrared light. Do not point at eyes, of course. But you'll also see there's actually sights on top of it because you have to aim it very specifically because it's a pretty directed uh, uh, beam of UV light and you can't see it. So it can be hard to know that you're hitting it properly. And you have to be about 10 feet away, right? Which is why I'm on a harness because I'm up on a lift, all about the safety. The downside, of course, is it gets heavy. That thing gets heavy after a while. But I'm like crouched down on the lift because I've got this thing braced on the handrail, aiming at it. Fire the laser beam. A lot of fun. Uh, so pretty cool. I quite enjoyed it. Uh, but we've had repeated issues with the two flame detectors at the uh, hangar door end, right? The giant opening wall to let the planes in. We had repeated issues at that end. They kept going into trouble. Uh, Now, it wasn't a sunlight issue, right? They're pretty insensitive to sunlight. Uh, we think that it was a temperature issue, right? Because it was going into trouble in the middle of winter. And when it's that cold, we think it was causing issues. One of the things in the right, so like they've got three different windows, right, and that's a little bit of a rain hat. You get a bigger rain hat for it. But one of the things it has is they have uh, window defoggers built in. You can turn them on or off. We turned them all on because we were having issues. And it keeps the temperature of the actual lens at 40 degrees Celsius. So fog does not build up. But it was only the one hanger, not the other hanger, but the two closest to the door, we had massive problems with them constantly going into trouble. So we ended up changing them from UV flame detectors, we changed them to infrared flame detectors. And that actually solved the issue. Of course, infrared flame detectors, when we were testing them, had to use a different ray gun because ID is something that's shot in the infrared spectrum, not in the ultraviolet spectrum. It's a lower frequency, so that it's a longer uh, wavelength. It's going to pick up flaming combustion, glowing, smoldering materials, and sparks, right? Because it's a lower frequency. It's actually a less heat, right? It's less intense. Uh, it picks up the constant wavelength of the glowing embers, but it also picks up the flicker of flame. The actual flicker, it's really good at that. Uh, Really, really sensitive, so we put a time delay on it. Right? It's not like the time delay that we put for status change confirmation. Right? We put it a one between 1 and 30 second time delay on because it's going to react that fast. The longer the time delay, the more positive the identification. But if someone If someone parks a vehicle and opens the door and you get that, reflected light off the door, that could set it off because these are also much more sensitive to sunlight and light and heating devices, right? Infrared tube heaters. Oh, totally set these things off, right? Absolutely an issue. Also, welders will set them off. Right? So you got to be careful with all that stuff. They signs got posted everywhere. No welding without permission and all that, right? Because they'd have to disable part of the firearm system for welding if they couldn't just block off the entire area from site. So there can be issues with that. With the infrared, there's different LED screens built in to filter out unwanted radiation. Uh, because they react so quickly, one of the other things that they get used on is conveyor systems because it can detect the fire on the conveyor as it goes screaming by. Right? Very, very effective on that. But again, issues from solar radiation. The day star can send it off. So there can be issues with that. One of the things that gets done, not as part of a fire alarm system, but they get put into manufacturing processes and stuff like that, or just the shipping of things like coal, movement of coal and uh, wood chips and sawdust and all that stuff. Uh, they can be connected to water sprayers to automatically douse embers so that they're not shutting down the production line, right? Because they're used for more than just uh, fire detection. The really expensive ones, you can go onto the YouTubes and nerd it up if you want. The flame detectors, you can get them with cameras built in, and they are completely optically based. And so you can you can put a little bucket of fire at the 50-yard line on a football field, and it can pick it up, and it'll actually pinpoint exactly where the fire is on the screen. Really cool technology. And you can, of course, tie that into a fire alarm system. Right? So the flame section detectors are really, really interesting, but incredibly rare because there are some pretty significant limitations with where you can install them and what they're susceptible to, and then the sheer cost. These things are very, very expensive. And so we use them very sparingly. The other issue being, of course, they are line of sight, so we have to make sure that we put enough in so that we don't have any obstructed views. We need to have some pretty decent overlap so that every single spot in the entire area to be protected is visible from at least one flame detector. Right, and that was an issue that we had with aiming uh, when they're moving around things like aircraft to make sure that when the aircraft is parked, we're still picking up everything around it. So it was pretty significant. But that is the end of our initiating device. Right? Of course, we have not started talking about the other stuff that we attach to fire alarm systems, you know, uh, with regards to sprinklers and all that stuff, because that is, of course, level 2. We can only learn so much at once. So we're going to call it a night. My blah blah muscles are getting very sore. That is quite a lot of talking. Next week, we're going to be covering signaling devices, much smaller module because there's not nearly as many devices used for signaling as there is for detection, and the concepts behind them are much simpler. So that's not going to take us a huge amount of time to get through. So next week going to be talking about signaling devices, and we're going to talk about the assignment and what is required for the assignment. If you've already opened up your assignment pages and had a look at it and had a little bit of a freak out, don't worry, it's not nearly as bad as it looks, right? Because we are going to go through it and discuss it, and there are some modifications that I have made to that uh, assignment. Uh, the because we still have not gotten the newest assignment. They have not developed the new assignment yet. That one is really on its last legs. It's the same assignment that I saw in 2003. It's been around for a very long time, and there's been so many changes to the world of fire alarm that uh, it's time for it to get replaced. But it does serve the purpose. Uh, it's absolutely not an issue. So yeah, uh, it's absolutely doable. It's not an issue. You guys will fine. Remember, this is this is an assignment. Assignments are for learning. This is not for testing your knowledge. This is for learning and getting better at what we're doing. You guys are going to learn a ton doing the assignment. So life is going to be great. So with that, that's enough for tonight. Uh, I hope you all have a great rest of the week and weekend and start of next week. And I will talk to all y'all next Wednesday.